Good evening, class. This is Dr. Boris with the next live session recorded that we're going to have Monday, 10 p.m. Eastern Standard Time. We were going to go over the M3, Module 3, Assignment 1, and a little bit of Assignment 3. First things I want to show you how are things done in terms of where do we go and what we do. First of all, we are going to look at Module 3, Assignment 1, and read it carefully, of course. There is a lot of text in the beginning. I'm recommending you don't really need to worry about creating new bell-shaped curves, etc. It's a bit cumbersome and complicated. What I'm suggesting, look what's inside of the assignment. The first things are that we have some practice problems and some grading problems. Problem 1 and 2 have links to answer, so they are answered problems that we can actually look at and practice with. So if I click the link to answer, it is going to give me a table that has case, that have mean seconds of concentration, which is explained in the assignment, and then z-score calculated. The writing in here is wrong, but it's not wrong, but it's kind of messed up. It's x minus mu divided by standard deviation, or x minus 100 divided by 10, because here we have mu, the average is 100, x is given value, and this is giving us formula. How is this column created? We're going to come back to this in a few minutes, few seconds if you wish. The similar thing is for the answer for practice 2, but practice 2 has less things done for you. You need to find out exactly what the p-values are for given the z-score amount. All right, so this is the basic understanding here. There was the explanation of what are we doing here is use the data and table below for following 4 problems. Use the stated mu and sigma to calculate z-scores, get the p-value 3 decimal places, and write out the formal APA statement of conclusions for each child. When you're finished with that answer, following question for each pair of parameters. Which child or children, if any, appear to come from a significantly different population than one used in the null hypothesis? What happened to the significance of each child's data as the data are progressively more dispersed, greater standard deviation? All right, first things first. So read this assignment carefully. You can skip first 2 paragraphs because they're not helping us too much in this particular case. If you carefully read it and practice, it's okay, but it's not necessary. Well, if you look at the first problem 1, linked to the answers, please trust what you see in the table, because that has been done many times and there are no mistakes in this particular table. Similar thing, when you go to table 2, I want you to practice to find the p-values. The biggest help for you to find the p-values is found in doc sharing and into the table which is on the bottom of doc sharing, which is called using the Steinberg table to get p-values from z-scores doc. So that's a Word document. If you click on it, you should be able to open it quickly. Open. All right, I will open it, and it tells you in details how to handle the z-scores that are negative and z-scores that are positive, and explains what to do with the positive z-scores, explain to you the bell-shaped curve and how we're calculating z, and how do we read p-values from the table. All right, so this is the steps how to read the p-values from the table, and why do we subtract a value from 1, etc., etc. Now, let me minimize this, and and I want to show you something else, which has to do with the online textbook, Vital Source Bookshelf. I hope I can quickly find it, because today I had to struggle a little bit to find my titles, because I have gazillions of titles loaded from publishers, even though I subscribed only to 2. But that's how they work. I don't know why is this happening. Let's see, maybe we can find this quickly, because table that we'll look is in the Steinberg, in the books class Statistics Alive, and that's in the back of the textbook, Appendix A. You will have normal distribution with the p-values and the z-values alike. So when we get here, let's say we can open this quickly. All right, here, that's great, that's fantastic. I'm going to open this. I will update later. I'll open the book. The book is going to open, and then I can go to Appendix A, normal curve table, and on the page, okay, let's see, Appendix A, page 515. Keep in mind, 515. There is a table that we can look the values. How the table works is the z-values are listed in columns, and then the p-values under the area next to it. So if we're looking to find what is the z-value for, what is the p-value for z of minus 2.60, we look next to it and we say that's 0.047. It's pretty clear, because if it's minus 2.6, it's 2.6 standard deviations from the mean, so it's going to be all the way to the left. So if you see that minus 3, z of minus 3 is way down, and it's 0.013, very small p-value, so it's a tail p-values. In the explanation in the textbook, you will see how to handle positive and negative z-values. Well, the whole story today is about a little bit of arithmetic and calculating those z-values properly, correctly, accurately, and finding the p-values by hand in the table, or by mouse, or whatever you want to call it. Well, that's the reason we need to have open this Word document telling us how to do it, and we need to have open this particular appendix thing so we can actually see what we're trying to do. And let's go back to our methods and analysis of quantitative methods and see what else we need to do. Alright, so the page 510 in an electronic textbook, we can actually read p-values and fill out the form. What is about the form? We have one more file that's a help file, which is in doc sharing, and it's called template. Let me see. Here's the template. I click, and if I'm lucky, I will be able to open it. And I can open it. It's a template that helps us to fill out the values from the calculations. Please don't send me problem 1 and 2. You practice in template and then send me tables 3 and 4. That's all I'm going to be grading, tables 3 and 4. Anyways, it's a template that we use. There is a recommendation of what to use in terms of decimal places, and we report p on 3 decimal places, and you can see the value. There are some values that are presented as 0, but they may have some very, very small values in there somewhere in the details and more decimal places. Sorry guys, I had to take a sip of water. And what else I want to show you? This is the template you're going to fill out. There is also something that's very helpful that you can in the assignment it's asking you to do. It's asking you to use the APA statement of conclusions for each child. That's somewhat simple, relatively simple. If you go to page 8 of this module 3 PowerPoint on the side, there will be a step-by-step hypothesis testing mode, and it tells you how to write a statement. For child 1, P was such and such, decision was retained null hypothesis, possible error type 2, and I want you to read about type of errors in the module 3. APA statement, the hypothesis is that therapy A improved concentration in child 1 was not supported, and you specify what was the X value, given X we're calculating, what was the Z, and what was the P. And you use the same format in the template and fill out tables 3 and 4 for me. If you want to do the 1 and 2, be my guest, but I don't really need 1 and 2, I need 3 and 4. So we download the template, and on page 8, page 8 we get the APA statement, and we apply it and write down in the template. So this is pretty much about module 1. Module 1 assignment, module 3 assignment 1, I'm sorry, assignment 1. And I'm going to go briefly over assignment 3, because assignment 3 is also application of Z. And don't get scared, because this is a word problem. And as I always tell my students, most of the answers, half of the answers on the word problem is in the problem itself. So, the graduate selection committee wants to select up to 10% of applicants on standardized tests with a mean of 500 and standard deviation of 100. What would be the cutoff score for selecting the top 10% of applicants, assuming that the standardized test is normally distributed? Hint for solving this, and there is a video related to this. Hint to this is to find out what is the corresponding Z for the value of p-value of 10%, 0.10, and since it's not listed under 0.10, you will get the closest value, the closest Z value that is in the table. So go in the table and look by hand, by eyeballing the values. And so you need to go down, and you need to go all the way down if need be. So you need to try to find the closest value to 0.1. Okay, 0.10. So you need to find the closest value, and I will let you do it. Find the p-value that is closer to 0.1, which represents 10%, and then pick the z-value here. Once you have that z-value, what you need to do, you need to go into oh nice, I closed this. I'll get this quickly back in. You need to go to the assignment and substitute what you have. So you're going to have the z value equals x minus x bar I mean the mean divided by standard deviation, which is all given in the Module 3, Assignment 3. I'm back in the Assignment 3. Okay, so for the first answer, after you find a z that corresponds to 10% of the p-value, you substitute in the formula that says that z equals, when you calculate z without knowing the numbers, you're going to say z equals x minus mu over sigma. Now what you have, you substitute. So you're going to say 1.28 equals x, which is unknown, which is the variable we need to look for, minus mu. What is mu? Mean is 500, and divided by 100. When you solve this equation for x, you're going to have the cutoff point, which is, I can't tell you the number, but it's easy to calculate from once you have the z value. The average commute time via train from Chicago, the second assignment is, the average second question in the assignment 3 is the average commute time via train from Chicago here to downtown is 60 minutes and a standard deviation of 15 minutes. Assume that the commute times are normally distributed. What proportion of commutes would be longer than 80 minutes, less than 50 minutes, between 45 and 75 minutes? If you looked at the Module 3 and the calculation of z values, you will find out that you can calculate the z value based on the value of 80. And again, we have mean of 500, standard deviation of, the mean of 60 minutes and standard deviation of 15. So you're going to start finding the z value for 80. And since we want to have more than 80 minutes, we're going to take the right part of the bell-shaped curve, and so keep that in mind. So we may need to subtract 1 minus the p-value of z being less than 80 minutes. And less than 50 minutes is easy. You calculate z, you figure out what the probability is, and please express those probabilities in percentages. Now, between 45 and 75, you need to calculate 1 for 75 and then subtract the probability for 45, and the difference is between 45 and 75 minutes. Same thing is for assignment 3, that Bob takes IQ test, find that IQ according to the test is 134. So that's x value for him. Assuming that the mean IQ is 100, his standard deviation is 15, and the distribution of IQ scores is normal, what proportion of the population would score higher than Bob, lower than Bob? That key question here, key thing here to calculate the z-score for 134, x equals 134, and we have standard deviation of 15 and mean of 100, and then what's from the left of x is the people there scoring less than Bob, and a little bit that's left on the right is going to be the people that are going to score above Bob. And that's all I had to tell you this evening. Good luck. Thank you. Send me an email if you need any questions. bjokic@argosy.edu. bdjokic@argosy.edu. Thank you.